This is the Chem 1 lecture over properties and changes of matter. So today we're going to go through both physical and chemical, both properties and changes. So you have this kind of T-chart at the top of your notes. We're going to go through each quadrant. First we've got physical properties. So that's something that's observed or measured without chemically changing that substance. And basically you can take all physical properties, so things you can observe: color, smell, shape, volume, and you can take all those different types of properties and put them into kind of two different categories, and these are important vocabulary words. We've got extensive and intensive. Extensive means it does depend on the amount of the substance, so mass. If I have a pound of bread and I were to cut it in half, the mass would then be halved. So the mass, whatever that is, does depend on amount. The more you have, the bigger the mass is going to be. Same thing with volume. If you've got more of something, it is going to be a larger volume. Those two properties do change when you start changing the amount. But something like the taste of the bread, well, the taste isn't really going to change if you take that loaf and you cut it in half. That's intensive. Intensive means that it's independent of amount. And see how the little IN is underlined? That's because it helps you remember that intensive is independent of amount. So color, doesn't matter how much of you have, grass is green, whether you have 30 acres of grass or you have 10 feet of grass. Luster means how shiny something is. Malleability and ductility are both properties used to describe metals. Malleability, if a metal is malleable, it means you can bend it and it doesn't break. Ductility has to do with being able to actually pull metals into thin wires. We'll talk a little bit more about those properties later when we talk about metals. Brittleness means when you bend it, it does break. Odor, smell, taste. Density is a big one that we'll spend more time talking about later. The texture of it, how hard it is, whether it conducts electricity or it conducts heat, the temperature that it boils, the temperature that it melts, whether or not it dissolves, all of those things are intensive. It's independent of amount. So properties, ways you could describe things chemically, it has everything to do with how things react chemically. So it's going to work a little bit differently. Depends on how easy it is for them to gain or lose electrons. Grouped together in periodic table based on those chemical properties. So as we go through and we start talking about the different areas of the periodic table, those would be how they react or don't react, or those things are considered chemical properties. So some examples, how they react: reactivity, combustibility, flammability, oxidation, which is probably a new word for you guys, but examples of oxidation are rusting and tarnishing, so you need to be aware that those are in fact chemical properties. That has to do with the chemical, the atoms or molecules rearranging. So next, down at the bottom of your notes, we've got this table listed here where we need to decide whether these properties are C for chemical or P for physical. So antioxidants are used as food preservatives in margarine. So let's think, is that talking about something physical or something chemical? Well, preserving foods means we're keeping it from rotting or going bad. So that's a chemical thing. The fact that white phosphorus glows in the dark, that's an observed thing, right? We're just looking at it. So that's just a physical property. Let's see, the fact that white phosphorus ignites easily, well, that has to do with flammability, right? Burning, so that's chemical. Sugar can dissolve in water. That is actually a physical thing. When you take sugar and you dissolve it in water, we still have sugar and we have water. It's now a homogeneous solution. We can't see it, but we can actually separate them still. And if we were to separate them, we'd still just have sugar and water. Let's see, the next one, gold does not react with water. That is a chemical property, or the fact that it's not very chemically reactive, but it has to do with chemistry, chemicals. Copper is ductile and can be used in wiring. So that's one of those physical properties saying, hey, we can pull it into thin wires. Gallium has a melting point of about 86 degrees Fahrenheit, so that's describing melting. That's another physical property. Iron rusts when it's exposed to air. Again, that's that rusting. That's chemical. Diamonds are the hardest substance known to mankind, so how hard it is physical. And last, silver is a good conductor of electricity. Conducting heat or electricity is physical. Next, we're going to talk about physical and chemical changes, so the bottom half of that quadrant there. So physical changes, so it means we're affecting this matter somehow. If it's physical, it changes the appearance of the substance, but we're not changing the chemicals of it. We're not changing the molecules or the elements that make up it. So we're having to do with changing the appearance of the substance, but we're keeping it chemically the same. So there's lots of examples of this. We can cut something in half. We can change the shape of it. The tricky ones, though, are phase changes. So if I can melt an ice cube, that's a physical change. I'm taking an ice cube, so ice is the solid form of H2O, and I'm melting it into liquid, so it definitely is going to look different, but those molecules are still H2O. So it's a physical change. And same thing with dissolving. So this is another tricky one. That's like earlier I talked about sugar water. If I can take sugar and dissolve it in water, sugar still have the same properties and water does. And I can also physically separate those two things. We talked about how we could boil or evaporate out the water and we'd still have sugar left behind. So that's still a physical thing. We're just making a mixture of the two. In the last quadrant are chemical changes. So this occurs when a chemical reaction takes place. So a new substance is formed with new properties. Energy is involved, whether it's being absorbed or released, and these things are typically irreversible. So they happen, we've got a new substance made, you can't really reverse it. There are 4 signs of a chemical change. A solid precipitate formed. That means when you mix together 2 liquids and you get a solid, it's called a precipitate. We'll talk more about that later. Heat or light being produced, that's energy there. Gas being produced if it bubbles. And a color change, but what's important, it has to be an unexpected color change. So if you're mixing finger paints and you mix together blue and red and you get purple, that's a very expected color change. That's not a chemical change, it's a physical one. But if we mix blue and red and we get yellow, that's very unexpected. Odds are that was a chemical change taking place. So next we've got we are looking at the atomic level, and we have to decide whether these are physical or chemical changes based on what we see. So this first example up here, I've got one beaker that contains little white dots, and I have a second beaker that contains a little bit bigger green dots, and I can see when they get put together, I have now a beaker that contains green dots and white dots. So those things did not come together, they did not bond. I still just have a mixture of the 2 different types of dots that I had in the beaker, so this is a physical thing. Nothing new was formed, I just now have those 2 things mixed together. It's just different in the second example. I've got black dots, I've got red dots, but then I notice when I put them together, I get these little Mickey Mouse dudes. The little black dots have actually bonded, they're touching the red dots, so I have a chemical change occurring. I've got actually 2 elements coming together to form a compound. So let's look at the next one. Now I've got the beaker of my Mickey Mouse dudes sitting on a hot plate. So we've got heat coming in here, and I notice what's happening is that liquid is turning into a gas up here. But if we look at those molecules, did anything change? Well, they didn't. All those molecules are the same, so that's still a physical change, right? This is actually boiling. That is a physical thing. We still have the same molecules, they just appear to be different. Our next one, let's see, I got a test tube here over a Bunsen burner, so we're adding more heat to it. But as we look at it, what's happening? Well, we are getting a gas up here, but if you look at that gas, it is different. So on the bottom of our test tube, we have molecules. We've got, blue and yellow together, but as this reaction happens, I'm getting individual elements. They're separated. So I have something different. So I started and ended it with something different. That is a chemical change there. So now we have to write a C or P to figure out whether it's a physical or chemical change. So first is erosion of a riverbed by water. That's a physical thing. We still just have dirt and river water where they've just changed the appearance. Now leaves changing color. So think about in the fall, that's actually when the leaves are dying, right? So that's actually a chemical thing that's happening. Carving a statue is physical. We just have smaller pieces of marble or whatever you're carving wood. Fireworks exploding, that's we're igniting, we're burning something, so that's chemical. Chocolate melting is a phase change, so that's physical. Same thing, dissolving, that's another physical thing. Cooking waffles, that's chemical. We've got bubbles being formed, so we've got gas being produced. Same thing with lighting a match, we're burning something, that's chemical. Photosynthesis, that is very chemical. Hopefully you remember that from biology. And let's see, a drop of hydrochloric acid on marble. This might be a new one. If you take an acid that's really, really corrosive and you put it on something like marble, it's slowly going to eat away at that marble. And it's not because of erosion, like lots and lots of hydrochloric acid flowing over it, like erosion of a riverbed. It's actually a chemical change.